Hello everybody. Today I'm going to review week 3 session because it was really important and I want to make sure we are really understand all the basics. The first one was we need to understand how to calculate pressure over a flat and horizontal surface. This is my tank and I'm going to fill it with some liquids up to this surface. The height for this liquid is h, and let me draw the pressure at the bottom or any specific height of this liquid. It is going to be something like this. Interestingly, as you can see, the pressure I draw for the bottom of this tank has a horizontal line, which means the pressure is uniform. So, if the pressure is uniform, we can easily calculate pressure as gamma h. And the resultant force also would be very easy, which is going to be gamma h times area. So whenever we have a uniform pressure, everything is really easy. You need to consider the height at the top of that level multiplied by gamma. Remember, this is going to be applied for any type of uniform pressure. So if you saw a pressure like this, which is uniform but vertical, again you are going to use the same formula. This is really important point. Most of question, they try to use this idea to trick you and make you mistake. Okay, so we learned this one, which is uniform pressure, and always you need to multiply the height above that level multiplied by gamma and A. We are done with this one. Let's get rid of this one. Now let's go for our specific case, which was the flat surface but with some angle. It is going to be this piece, which is part of the whole a larger piece, and we are going to have liquid, for example, up to this level. So there's liquid there, and this is our free surface. This point is going to be our origin. What else? And this is the general angle we have for this surface. We have a few important points here. First, you need to know how to draw the axis. So y-axis is going to be exactly here, and x-axis is going to be perpendicular to our surface. So if I watch this surface from this side, it is going to be like this. Oh, I didn't want to use green. And this is y-axis and this one is x. Done. We have two very important points here. We call one C and the other one CP. C is the centroid, CP is center of pressure, and always CP is below C, which is centroid. And CP is the position our resultant force is going to be applied. We have a few important points here. CP, the distance of CP from origin is going to be YR. The distance from centroid from origin is going to be called YC. We have two. Oh, I made a mistake here. Let me fix this mistake. So this is YR because CP is here. CP. And also we have vertical distances. So I'm drawing like this. This is going to be HC. And the other one is going to be HR. So you need to know how to convert YC and YR to HC and HR. They are related to this theta. Okay. So let's write the formula for that. We said resultant force magnitude is going to be gamma HA. Wow, this is exactly similar to the formula we had. And I said, be careful. This H is going to be HC, not every H. So if you want to find magnitude of the resultant force, you need to use HC, which is the height from centroid, which is this one. Oh, not that good. So let's delete this and use HC here, and now we understand. Okay, so I can extend this formula and say gamma, instead of HC, I want to convert HC to YC. So it is going to be YC times sine of theta times area. These two equations are exactly the same. So up to here, we found the magnitude of resultant force. Now it's time to find the position of CP, or center of pressure, which resultant force is going to be applied. We have two components, YR and XR. We need to find those two. YR formula was moment of inertia about x-axis from centroid is going to be divided by YC times area plus YC. Remember, I told you always center of pressure is going to be below center of centroid or geometrical center. The reason is here. This is a positive number. This is also a positive number. So YR is going to be always bigger than YC. Okay, great. Let's write the next formula for XR, which is going to be moment of inertia for XY about C centroid divided by YC area plus XC. Okay, let me tell you something. Most of the students, they understand these two formulas, they use it very well, but there is a small point here. Be careful about this YC. Oh, sorry, I dropped my pen. Be careful about this YC. Although this part is XC, the other part is YC. So you need to be careful when you are using this formula. One point, whenever our area, when area is symmetric, I xy about C is going to be 0. So if this shape here was symmetric, IXYC is going to be 0. So XR is going to be XC. So XR is going to be exact position of X for centroid. Again, if you draw your y-axis in a way to pass through this centroid, this XR is going to be equal 0. So it's a good idea to select good X and Y axis. Okay, we learned this one. These formulas were for general purpose. Now I want to show you a simple case. Let's delete this. We learned enough about this. Okay. A simple case. I have a vertical wall and fluid level is here. Not yellow, I selected blue. Okay, this is free surface. Let's draw the pressure over sidewall. It is going to be start from 0 to a maximum pressure at the bottom, and we know why, because pressure change just by height. More depths, higher pressure. So if I asked you what is the pressure here, you are going to say this pressure is going to be gamma h if this height is h, and we are going to have our resultant force here. Okay, let's see. I want to find the magnitude of resultant force. I know the formula was gamma HA, but H is HC. So let me check. This part is like a pressure at the centroid multiplied by area, which is good. and it is going to be gamma centroid is h divided by 2 times area. Beautiful. So I found the magnitude. Let me draw a 3D shape of our pressure. I do my best, but I'm not promising it is going to be nice. Not bad. Okay. So this is my pressure. This is the maximum pressure. Let me make sure you understand. Pressure at the bottom is going to be gamma h. Pressure at the top is going to be 0 because it's a triangular shape, 0 there. And this is our h. And this is b. And this one is gamma h. And we said our beautiful resultant force is going to be here, somewhere at the center of this line, because it is symmetrical, it's a rectangle, so we know xr is 0 if y was this way, and x we can calculate. Okay, so we found the magnitude here. Let me show you. This is our magnitude. Let's find the position. So the formula was the formula was yr is equal ix around c yc area plus yc. Let's write the formula for the value for each. Ix and c, if you check the tables, it is going to be b h power 3 divided by 12. Area is going to be b h. What else? Yc is going to be h divided by 2. Now we have all the information. Plug in inside the formula and you are going to get 2 over 3 h from top. So if I want to show you the position, it is going to be from here to here, 2/3 of h, from here to here, h divided by 3. Okay, for this case, theta was 90 degree, and we used everything, the previous formula I introduced. Let's study one more case. This time, my tank, or the area of the wall I want to investigate, it is going to be submerged. So I would like to investigate this piece and force over this piece, and this piece is part of this area. And water level starts from here, so a little from above are the area I want to investigate. So this time it's a bit different. Enough. So free surface is going to be here. If I draw pressure, it is going to be like this. And I'm looking for the pressure just for this piece. And we have other pressures here. Gradually increases and linearly reaches to higher levels of pressure. This is H1 and this one is H2. Let me redraw this pressure of just this piece, which we are interested. So I'm just drawing the pressure for that piece. It is going to be something like this. I have pressure here, 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 here. I'm going to divide this type of pressure area to two separate parts. This part is kind of have a uniform pressure which is applied to the sidewall, and I know how to calculate uniform pressure. And let's use blue for the resultant force of this piece. Because it's a uniform pressure, the resultant force should be at the centroid. And I'm drawing like this and I'm naming it F1. For triangular section, this one, I'm going to name another resultant force. It should be a bit lower, for example here, and I'm calling it F2. Let's add some dimensions. Let's call this one Y1, this one Y2, and finally we are going to have a resultant force. It should be here, for example, and I'm calling it FR, the total resultant force, and that height we are going to call it YR. First of all, we know what is this distance. We talked at the beginning of this review. It is gamma H. 1. Yeah, because of the top area. This piece is going to be gamma H2 minus H1 because I already considered the H1 part. Now everything is really easy. Resultant force is going to be combination of F1 plus F2. To make sure you understand where is F1 and F2, I'm going to not maybe this color, use this color to show you this point A, B, C, D, E. So F1 is going to be a force for A, B, D, E. And F2 is going to be B, C, D. Done. So now we have very good understanding. Let's put the values. F1, as we talked, first section, it is going to be gamma H1 multiplied by area. For F2, it is going to be, remember the formula was gamma HCA. Gamma HC is a half, so it is going to be H2 minus H1 divided by 2 times area. Done. I found the magnitude of the resultant force. Okay, now I want to find the position, which is YR. And it is going to be based on the moment of FR and F1 and F2 from the top side, for example, point A. So, FR multiplied by YR must be equal F1 multiplied by Y1 plus F2 Y2. Those momentums must be equal. I already know what is F1, what is F2, and we know Y1 is, let's write this distance as H. I don't want to repeat H1 and H2. So Y1 is going to be half of H, and Y2, Y2 is going to be 2/3 of H. Why? Because previous section I showed you how to calculate this one. Therefore, YR is going to be 1. F1 Y1 plus F2 Y2 divided by FR. And we found our position. Done. Let's go and review the final one, which is bended surface. Okay. Let's draw a horizontal area of importance and horizontal. This one was vertical, the other one horizontal. Sorry, sometimes I'm using wrong words, but I'm doing my best to not make a mistake, but sometimes it's not possible. Okay, now I isolated that piece. I'm taking out that piece and investigating it. So this is the piece we are going to investigate. Let's use some points A, B, and C. Okay, let's use the resultant forces. This is horizontal, so we are going to have uniform pressure at the above this point, at the center, and we are going to call it F1, and you know how to calculate it. We have vertical surface, exactly similar to the previous one, previous point I made. It is going to be applied a bit lower than centroid, and we are going to call it F2. Let me draw the pressure here. It is going to be like this. Pressure here is going to be like this, uniform. And you know how to take care of both. And we are going to have reaction forces, horizontal component of reaction force, and this one is vertical component of reaction force. And one more, this is our centroid, and we are going to have weight. And you know weight is gamma times volume. Okay, because of summation of formula at x and y direction, we can easily see that Fh must be equal F2, and V must be equal W plus F1. And because we have two components, horizontal and vertical, the final magnitude of resultant force is going to be square root of Fh power 2 plus Fv power 2. And the angle of Fr, let me draw like this. This is our Fv. Angle alpha is going to be tangent of alpha, the opposite f v over the side fh. Done. So we find the magnitude and the angle. Now we need to find the position. Okay, how we can find the position of Fr? First of all, we have vertical position. Okay, let me select a color. Vertical position for Fh must be equal of vertical position of F2. So I'm calling this YH. Why? Because if the vertical position of F2 and H2 wasn't equal, they are going to create momentum and we don't have equilibrium. So they must be at the same level. Interestingly, you know how to calculate the position of F2. I just told you how, using YR formula, which was YC plus IXC divided by YCA, and you know YC, if you consider this height as D and this height as HS and this height as LS and the depths as WS, you are going to have YCD plus HS divided by 2. Why? Because, where is it? This is D and this is HC, because centroid is going to be half of HC and we add D to reach the surface. Let's calculate the other. Area is going to be WS, depths, times HS for the side. And IXC is going to be HS power 3 times WS divided by 12. And YH is going to be the total distance from this point, which is our kind of 0, which is going to be D plus HS minus YR, because YR was here. Okay, we found YH. Done. Now we need to find XV, which is going to be this distance. To find that point, I'm going to find moment about this point. And let's call it what we call it, let's call it I. If I select other point, I'm going to have trouble, but by selecting this point, I basically getting rid of F2 and FH, because both of them are passing that point. using that formula, I can find moment about point I, which must be equal 0 because we have equilibrium and counterclockwise positive. So Fv times xv minus F1 times Ls divided by 2 minus W times Xc must be equal 0. What is Xc? Xc is here. It's centroid. If the shape is, you know the centroid of the shape, sometimes you know some of the centroids. If you don't know, usually we have some tables to find those centroid positions. And you can easily find xv using all the available information here. Wxc divided by Fe, and we're done. Okay, thank you very much and see you next time.